Hi everyone. In today's lesson we're looking at Chapter 6, Section 5, Trapezoids and Kites. We're to use the properties of trapezoids and use the properties of kites. Our standards are GSRT 5. We start with some vocabulary. Trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. In this trapezoid you can see that these two lines are parallel. In this one we have these two lines that are parallel. Bases of a trapezoid. The parallel sides of a trapezoid are called bases, so the two lines that are parallel to each other are called the bases of the trapezoid. Base angles of a trapezoid. A trapezoid has two pairs of base angles. Each pair shares a base as a side. So in this trapezoid over here we have a base angle of this and this. We also have base angles up on the top over here. Legs of a trapezoid. The non-parallel sides of a trapezoid are called legs. The sides over here that are not the bases of the trapezoid are considered legs. Isosceles trapezoid. An isosceles trapezoid is a trapezoid with congruent legs. This is an isosceles trapezoid because the two legs of the trapezoid have the same measure. Midsegment of a trapezoid. The midsegment of a trapezoid is the segment that connects the midpoints of its legs. So we have AD and BC, which are the legs of the trapezoid. We have PQ over here, which is the midsegment of trapezoid ABCD. And you can see this is the middle point, so it cuts AD into two congruent halves, and it cuts BC into two congruent halves. Kite. A kite is a quadrilateral that has two pairs of consecutive congruent sides, but its opposite sides are not congruent. In this kite over here, we have line segment GF and EF. These two sides are congruent because they go right next to each other, and you can see that the two sides have the same measure. In the same token, we have DE and DG. These two line segments are congruent, and they are consecutive sides. But the opposite side to DE, which is GF, are not congruent. The same thing can be said with DG. The opposite side of DG is EF, and those two are not congruent either. Theorem 6.14. If a trapezoid is an isosceles, then each pair of base angles is congruent. So we can say that angle A is congruent to angle B, and angle C is congruent to angle D. So in this picture over here, angle A is congruent to angle B, and angle C has the same measure as angle D. Theorem 6.15. If a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. ABCD is an isosceles trapezoid because angle D and angle C are congruent. Theorem 6.16. A trapezoid is isosceles if and only if its diagonals are congruent. ABCD is isosceles if and only if AC is congruent to BD. Example 1. Using properties of isosceles trapezoid. WXYZ is an isosceles trapezoid. Find the measure of angle X, the measure of angle Y, and the measure of angle Z. We know that WXY is an isosceles trapezoid, so the measure of angle X, which is right over here, is the same as the measure of angle W, which those are the base angles, and so we have the measure of angle X is 110 degrees. Angle W and angle Z are consecutive interior angles formed by parallel lines, so they are supplementary. This means the measure of angle W plus the measure of angle Z is equal to 180 degrees using the consecutive interior angles theorem. We know the measure of angle W, it's 110. So we have 110 plus the measure of angle Z is equal to 180 degrees. Subtract 110 from each side, and we get that the measure of angle Z is 70 degrees. We know that the measure of angle Z is congruent to the measure of angle Y, because this is an isosceles trapezoid and the base angles are congruent. So WXYZ is an isosceles trapezoid, so the measure of angle Y is equal to the measure of angle Z, which is equal to 70 degrees. Alright, checkpoint problem number 1 is yours. Complete the following exercise. ABCD is an isosceles trapezoid. Find the measure of angle A, the measure of angle B, and the measure of angle C. Example number 2, using properties of trapezoids. We have to show that HIJK is a trapezoid. In order for HIJK to be a trapezoid, we need to have two sides that are opposite and congruent. The other two sides cannot be congruent. If they are congruent, then this is not a trapezoid. It's either a parallelogram or a rhombus. So let's start by looking for the slopes of each of these line segments. Remember, the slope formula is lowercase m is equal to y2 minus y1 over x2 minus x1. So let's find the slope of line segment HK. We have 8 minus 6 over 4 minus 0. Simplify that, we get 2 over 4, which reduces down to 1/2. Now let's look for the slope of IJ. That's 3 minus 0 over 9 minus 3, which simplifies down to 3 over 6, which reduces to 1/2. So we know that the slopes of line segment HK and line segment IJ are equal, so line segment HK is parallel to line segment IJ. And to show parallel, we put little arrows in the middle of the line segment. Now let's look at the slope of HI and JK. Slope of HI is 6 minus 0 over 0 minus 3, which reduces down to 6 over negative 3, which simplifies to negative 2. Slope of line segment JK is 8 minus 3 over 4 minus 9, which simplifies to 5 over negative 5, which reduces to negative 1. The slopes of line segment HI and line segment JK are not equal, so line segment HI is not parallel to line segment JK. Because line segment HK is parallel to line segment IJ and line segment HI is not parallel to line segment JK, then HIJK is a trapezoid. Theorem 6.17, midsegment theorem for trapezoids. The midsegment of a trapezoid is parallel to each base and its length is 1/2 the sum of the length of the bases. Line segment MN, which is right over here, is parallel to line segment AD. It is also parallel to line segment BC. The formula to find the midsegment of a trapezoid is 1/2 the sum of its bases. So in this case, it's 1/2 AD plus BC. Theorem 6.18, if a quadrilateral is a kite, then its diagonals are perpendicular. So we have line segment AC is perpendicular to line segment BD. Theorem 6.19, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. In this kite, we have angle A, which is congruent to angle C. So angle A, which is opposite to angle C, is congruent. And angle B is not congruent to angle D. Example number 3, angles of a kite. We have to find the measure of angle S plus the measure of angle U. From theorem 6.19, we know that angle S and angle U are congruent because STUV is a kite, so angle S is congruent to angle U. The measure of angle S is equal to the measure of angle U. 2 times the measure of angle S plus the measure of angle T plus the measure of angle V is 360 degrees. This comes from the sum of the measures of interior angles of a quadrilateral, which is 360. Substitute what we know. We have 2 times the measure of angle S plus 73 plus 37 is equal to 360. Subtract 73 and 37 from 360 and simplify to get 2 times the measure of angle S is equal to 250. Divide both sides by 2 to get the measure of angle S is 125. So we know that the measure of angle S is equal to the measure of angle U, which is 125 degrees. Alright, checkpoint problem number 2 is yours. Find the measure of angle X and the measure of angle Z. That's it from me. I'll see you all soon.